Good morning or good evening or good afternoon, guys. Welcome back to Math 135. This is 3.7. We're in the last section of chapter 3. We're talking about rational functions. Rational functions, all they are is what do you get if you divide a polynomial by another polynomial. And I'm just going to jump straight into question number 1. We're looking at, if you haven't read the first box, read the first box, how to find the domain and how to find any necessary restrictions. This is f of x equal to x plus 1 over x minus 2. The first thing you want to do whenever you're dealing with rational function is factor. But in this case, it's already factored. There's only one simple one. And I'm looking for, when I'm asking the domain, what is going to make it 0 on the denominator? Because then I'd be dividing by 0, which we know is impossible. Here, 2 is going to make this 0. 2 minus 2. So we say x cannot be equal to 2. That's the one restriction. Now, as a domain, that means everything except for 2. So I write that like this as an interval, negative infinity up to 2. And then take out that 2, start from 2 again to positive infinity. So that's the answer right there. Okay, easy. Let's go on to number 2. Oh, as far as necessary restrictions, in this case, there are no necessary restrictions because it's already included in the original function. Now, what I mean by that is, or I'll tell you what I mean when we get to a question that has necessary restrictions. And I'll show you the distinction. This one, number 2, is actually going to have some. It's x plus 1 over x squared minus x minus 2. All right. Actually, I have a small issue with this. When it says to find necessary restrictions, I don't feel like that's fully an important question. I think you should just ask, what are the restrictions, period? What are the overall restrictions? Well, like I said, to find, whenever you have a rational function, you always want to start by factoring. So the top is already factored. The bottom is the piece that is not yet. So let's factor it. I need two things that are going to multiply to negative 2 and add to negative 1. Looks like negative 2 and positive 1. So at this stage, before I do any simplification, this is where I want to write down my restrictions. My restrictions are x cannot be equal to 2 and x cannot be equal to negative 1. Okay, these are all my restrictions. So from there, I can figure out my domain right away. The domain is everything except for these two values. So it's going to be negative infinity up to negative 1, union negative 1 to positive 2, and then union from 2 to infinity right there. Okay, that's the domain. The domain always comes from looking before I do any simplification. Now, from here, I can simplify though, right? Because x plus 1 is going to cancel. So my original function is actually equal to, let's come down here, equal to 1 over x minus 2, right? So this is the end result of my function, but I have to keep in mind, so this is the equivalent version of my original function, except for one caveat, that I have this necessary restriction, which is that x cannot be equal to negative 1. So our original function is, for all intents and purposes, equal to 1 over x minus 2, except for x cannot be equal to negative 1. Otherwise, the graph will look exactly the same, except it just has a hole right where x is negative 1. Okay, at this time, I'm going to actually take a pause here from doing questions. I want to show you a conceptual idea, something we've actually seen before. So let's think of, if I wanted to graph the function y is equal to 1, or f of x equals to 1, what would that look like? Well, that's a horizontal line, right? It's just this line here, right at 1. Okay, I know my line is not straight, but just use your imagination. This is 1 here. Yeah. So this is the graph of all the values where y is equal to 1. Now, if I was to look at this function, what is y is equal to, let's say, x minus 3 over x minus 3. Here, I could simplify this, right? Because anything over itself is just equal to 1. Yeah. However, I have a restriction because if x is equal to positive 3, then I would be dividing 0 by 0, which does not make sense. I can't divide by 0. So restriction, necessary restriction, is x cannot be equal to positive 3. Now let me graph that side by side. So what does the graph of y is equal to x minus 3 over x minus 3 look like? Well, that looks like the exact same picture. Let me give myself a little space here. It looks like the exact same picture, except right at 3, we have a little hole. Cannot be that number. Right at 3, it cannot be that. So I have a little gap in my graph, but otherwise it's the same. Yeah, so that's what's going on with these necessary restrictions. You have it reduced to something, but it looks slightly different because it cannot be something where you're dividing by 0. All right, let's just move on with the question. So I'm gonna try just crank out numbers 1 through 5 in this first video, and then we'll continue on from there. So number 3 is f of x is equal to x squared minus 3x plus 2 over x squared plus 4x plus 3. So like I said before, first thing I want to do with rational functions is I want to factor. So the top is x something plus, actually it's gonna multiply to 2 and add to negative 3. That looks like negative 1 and negative 2. At the bottom it should add to 3, sorry, multiply to 3, add to 4. That looks like 3 and 1. X plus 3, x plus 1. And there's nothing that's going to simplify, right? So I'm going to have no necessary restrictions. I do have overall restrictions. X is equal to negative 3 and x equal to negative 1. So the distinction between a necessary restriction and an overall restriction is at the end of simplifying, I don't see my necessary restrictions. They kind of disappear from view, but they're in the background. All right, I still do have a domain. Domain is everything except for these two, so that looks like negative infinity up until negative 3, then from negative 3 to negative 1, and then from, sorry, that should be union from negative 1 onwards towards infinity, like that. Okay, necessary restrictions, like I said, there are none, because all the restrictions are clearly visible at the end of simplifying. Alright, that's number 3. So number 4. F of x is equal to x squared minus 1 over x squared plus 1. Okay, so we got to factor this thing. The top factors to x plus 1, x minus 1. But the bottom is actually unfactorable. It has no factors. Because if I look at my, what is it? If I look at my law of sines says my factors can only be positive or negative 1. If I put negative 1 in or positive 1, either way it's not going to be 0. So there's no zeros, which means there's no real roots. There's no real zeros. It does have imaginary roots, but that means I can't factor this. So I'm just going to leave it like that. All right, what does that mean in terms of my domain then? It means there's nothing I can put in here that's going to make the bottom 0. So the domain has no restrictions. And there are no restrictions at all, period. So the domain first is going to be negative infinity to positive infinity. And we have no necessary restrictions. Okay, that's 4. That's an easy one, but kind of a little tricky because it has nothing, no restrictions. Okay, number 5. X squared plus 3x plus 2 on the top, and the bottom is just x plus 2. So again, always factor if you can. This is x plus 2x plus 1, it looks like on the top. And the bottom is x plus 2. Alright, before I do anything else, I want to write down my restrictions at this point. x cannot be negative 2, because that would make this 0 on the bottom. But after that, I can reduce. So x plus 2 divided by x plus 2, those cancel. I have just x plus 1 left over. So the overall function is going to look just like x plus 1, except it's not going to be equal to negative 2. X cannot be negative 2. What does that mean for the domain? Domain first, everything except for negative 2. So negative infinity up to negative 2, union from negative 2 to infinity. And the necessary restriction, that's the restriction that is not apparent looking at the end result here, but it's still there in the background. X cannot be negative 2. So that is it. That's numbers 1 through 5. That wasn't so bad, right?